All right, today we are starting a new unit or lesson 33. It's on symmetry. Who wants to tell me what they know about symmetry? What do you know about symmetry? What do you guys know about symmetry?
I know.
Okay, Jocelyn, tell me what you know about symmetry.
I know that symmetry is when you put a line either across or when you draw or imagine a line on a shape letter, anything like that it always has to be symmetrical to be a line of symmetry on a shape, letter, or whatever.
Okay, so you put a line to show a line of symmetry. All right, what you got? You fold something, get your foot out of there. Thank you. If you fold on the line, it'll line up. Okay. Anyone else? Yeah, line of symmetry is a line you draw down the center of an object where if you fold it on that line, it will line up. On the globe?
No, that's the.
Well, that's like the equator, I guess, could be, but we're not talking about globe draft. It could be, sure. You'll see examples of circles, but not right now. And it doesn't say, oh, the globe's not a circle, physically it's a sphere, and blah, 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 blah. I don't want to hear it. Emerson. Okay, everybody go, take your hands. Take them out like this. Put them together. Put the heels of your hands together, your palm, then fold it down. Chances are, if you look, it is matched up. Some people have fingers that might be slightly bigger or smaller than another one. But for the most part, when you fold it over, it lines up. That's a line of symmetry. You should fold over and it should line up exactly. Okay? So let's take out our MIBs and open up to page. What page is this? Page 402. 402. On page 402 in our MIBs. You notice those lines that are drawn on the shapes, they are dotted, okay? And they're also a different color, just so it stands out. So each figure below has a dashed line drawn across it. Imagine folding each shape along the dotted line. If the two parts would fit exactly on top of each other, when the shape is folded, draw a star on the shape. So go ahead and just look at it now. Before we go through shape by shape, draw a star is if when you fold it over, they would match up. Okay, just do this on your own. We'll be checking this over together. Draw a star. If you're like, oh, I can't draw a star, just do like an asterisk where you just draw lines. that your star? I can see that and that. And that's a Y and the two X's. At least put like a third one in there so it looks like an asterisk. Okay. What I'd like for you to do, it says to trace the square. We're not tracing. Okay? What I'd like for you to do, unless you just have this on your computer screen, then obviously trace it. Take your book, okay? Take your book. We're not going to tear it out, okay, the page out, but coming in from the side, go through and cut the shapes out, okay? Cut the shapes out. Cut around the shape. Do not cut the red line. For instance, if I'm cutting this square, do the best that you can. Cut around the outside on the blue line. And it will look like this. Okay? It will look like this. Yes. You need to borrow scissors? Yes. Yes, Addison.
No, that was me. The team.
Oh, yes, the team up.
What page did you say we were on? Because I heard 406.
We're on 402. 402. Go ahead and cut the shapes out. Give you a couple minutes. Anybody else need scissors in the classroom? Yes.
I want question A.
Yes, but what I would like for you to do, yes, right now we're just cutting all of the shapes out, okay? So we're not exactly following along right now, because the first one's like trace and cut out. We're just cutting them out right now. But don't just play with them. After you cut them out, don't worry about folding them over right now. I just want you guys to cut them out. What are you doing? No. That's why I said come at from here. Okay. There you go. Because again, you're not going to be using this, so don't worry about cutting out the side of this page. You're fine. Worry about cutting the shapes out as fast as you can, especially the circle gets kind of tricky. Okay. And circle. Yes.
I can't find any scissors.
All right. Well, you will just have to kind of. What I'd like you to do, whoever, because I can't see, is that Addison or Fatima? Fatima, go ahead and just tear out page 402. Then you'll be able just to fold the shapes that way, okay? Just pull the entire page out. Like Kenley sat there and just kind of did a rough cutout of the shapes. Now she's turning them down. Remember, we're just cutting out the outside of them. We're not cutting out the dash line, okay? Ask me where we're going to fold it to see if that is a true line of symmetry. Okay, once you have the square cut, everybody should yes. You can find your what? Right there. All right, so A. So we all at least have our square cut out. We all at least have our square cut out. Fold it on the dashed line. Do the two parts fit exactly on top of each other?
Yes.
Yes. So go ahead and write in the dash, yes.
Dash. What?
On A. The dash after A. The line after A. Just write down yes. Now the rectangle. So that second shape, it goes square, isosceles triangle, rectangle, circle, right triangle. So take a look at the rectangle. When you fold over on the dashed line of the rectangle, does it match up exactly? Right, yes or no. Then say why or why not. We're on B now. Now we're on B.
This triangle or this triangle?
We're doing the rectangle. We're on B. Go ahead and fold. What?
I don't get how to explain why it's not.
What? Why are they not matching up? Explain. What does it look like? Okay, when you folded the rectangle, did it match up? Raise your hand if you say yes, it matched up. Good, because if your hand was raised, I would say you did not fold it on the red line. You cannot go corner to corner on a rectangle. They do not match up. All right? They will not match up, yes.
On a rectangle, can't you go down?
But we'll talk about that. But if you do it from corner to corner, it's not symmetrical. Okay? Because the corners do not match up. That's what I would say for my Y. No, because the corners are opposite of each other. They do not match. C. Which other shapes are divided into two parts that fit exactly on top of each other? So we talked about the square. There are two more shapes when you fold them. The second one is an isosceles triangle. And we talked about the rectangle. It does not match like that. Circle, and then a right triangle. So it's either going to be two of the following. Isosceles triangle, circle, right triangle. Right triangle. Right triangle is the one that's on the far right. This one is the right triangle. Has a right angle at the lower left-hand corner. And after you answer C, answer D. Which other shapes divided into two parts do not fit exactly? Basically, it's going to be the other one that you did not already write down. Either the isosceles, circle, or right triangle for D. Which one of those does not match up? You know, like 30 seconds. Well, I can tell Audrey's been here. want to keep it, it's not a puppy. What? No. You'll have to bare fist it if you want to take out tonight. Well, I don't know. You got it. Yeah. See what I saved you from?
Trayvon wanted to do.
Is this what you're gonna do?
Please don't. I prefer you not.
Yeah.
Are you still even? Yes, I still have my resistance. I prefer you. Then never.
No, that would hurt just as much because it's only that thick. All right. Now, and it would hurt me just as much as you. Because if we're going to talk about that side topic. If boxing gloves are nice and padded, okay, so their hand does not, it still hurts, but it doesn't hurt as much as if they did not have one at all. So they hit even more, even harder, because they know it's going to hurt you, not really going to hurt me as much. Use your bare fist.
It's going to hurt.
It would hurt if I sat there and hit somebody in their head. I would break many bones, along with who knows what would happen with my neck. Okay? So you would think, I heard a whole podcast about this. It was about the physics of boxing. Like rugby, it's a lot like football. Their pads are not like football. Football pads, they have layers and layers and layers, so they can get really knocked up and they won't break very many bones. But rugby, they still have some pads.
It needs a pad up. I saw a guy and had his hair all the way turned around.
Yes. But, so rugby, they still do scrums, but they don't sit there because they don't have that much pad, so they'll end up hurting themselves as well as the other person. Okay, C. What other shapes, when you divide it, does it fit exactly on top of each other? Coy, give them to me. A cute triangle? Sure, you can call that a cute triangle. I'd call it an isosceles, but that's a cute triangle. You're right. So, is Coy correct? The acute triangle and circle. That's exactly correct. So, knowing that, Cohen, what one does not fit? The right triangle does not fit when you fold them on the line. Well, but we already talked about the rectangle. But yes, the rectangle as well. So E, describe what parts that fit exactly on top of each other look like and what parts that don't look like. So what shapes? What do the shapes look like that fit on top of each other? And what are the shapes that don't? What do they look like? Just think about it. Not in any hurry. Not in any hurry. Bless you. You're welcome. And what did you write down on this one? Coy, I just called it. And I love hearing the sound of your voice, but we're going to let somebody else have a shot. Chloe.
The ones that
Okay, that are symmetrical, that fit exact.
they have a line straight through it, and the ones that are not, they're like this, have like diagonal.
Okay. Ones that, yeah. Because if you look at the, go back up here. The ones that, well, I guess the triangle kind of goofs that one up. ones that fold I don't know what it could. When it, describe how it's drawn. It's drawn down the middle of the shape. It goes through the center, but the rectangle technically it goes through the center. It's just drawn correctly because, like, who said it? I forget who. Maybe Parker said it. With the rectangle, you can draw it straight up and down or on the side, and it would be able to fold and be symmetrical. So it does have a shape. All right, now go ahead and look at the next page here. In the problem on the previous page, you tested folding each figure along a line to see if the two parts fit exactly on top of each other. When you can fold a shape on the line and the parts line up with each other, the line is called a line of symmetry. Lines of symmetry were shown on the square, the isosceles triangle, and the circle. Shapes can have more than one line of symmetry. All of the lines of symmetry in a square, are shown on the right. Notice all four lines of symmetry pass through the center point of the square. So the square has four lines. You can go corner to corner, corner to corner, straight up, straight down. 1, 2, 3, 4. Okay? Scalene triangle has 0 lines of symmetry. If you're drawing the lines in the triangle so they parts fit exactly on top of each other, you can't do it. There's no possible way I can fold that one time and have everything match up. Okay, it has no lines of symmetry. That's what you would write. 0 lines of symmetry or no lines of symmetry. To the right are 2 different quadrilaterals. The rectangle has 2 lines of symmetry, which go through the center point. That's what Parker was talking about. You cannot go corner to corner, but you can go up and down, horizontal and vertical, as long as it passes through the center point. Okay? But the other quadrilateral, that one doesn't. Some shapes just don't have a line of symmetry. Okay? Now, describe a shape in your classroom or your room you're in, you're at home, that has at least one line of symmetry. Go ahead and describe it. Kind of name the shape and describe what the lines of symmetry are. Figure out what that shape is and write about it. If you want to draw it, draw the shape, and then draw the line. That would be fine as well. That's fine. I just noticed that. A lot of people do that same mistake. Okay, what shape or what item did you pick? Cruz's friend Cohen.
A rectangle and my desk.
Your desk, rectangle. Okay. Boy, I already heard your voice. You know, I only can hear every student's voice only one time an hour, or I go crazy. I kind of malfunction. And like Hermione. Okay. Bryson.
My Chromebook, it has 2 lines of symmetry, both left to right and top to bottom.
Okay, very good. Emmy. Flag. What are the lines of symmetry in the flag? Okay. This was also in a cubby. Is this anybody's? Yours? Okay. So you'll put it over here so you can put it away when you get a chance. Anybody name something that's not a rectangle? And yes, rectangles have them. So if you say a rectangle, I'll Hermione on it. All right, go.
The clock up there has 4 lines of symmetry.
And what shape is a clock?
It's a circle, so it has up and down, side to side, and then it has the 2 right here.
And what our young Gavin doesn't realize is that he just made an opening for Mr. Hall to talk about his favorite thing, infinity.
What does infinity mean?
Endless.
Endless. A circle a true circle has an infinite number of lines of symmetry. You can always make them a little closer. As long as it travels out the 2 outsides, it goes through the center point. It is a line of symmetry. Oh, and not the other one. Some way to make a circle on here, because obviously it's hard to make a true circle. So I will do this. Somebody unplug the microphone and bring the my Chromebook over here, my whatever over here.